session there. Now, I have got Steve Carlini coming up next from Schneider Electric to lead another great fireside chat. Right? So Steve, if you can come on up, he's got to make his way through the chairs. Where is he? If you see someone frantically running up here, trying to make his way through the crowd here, Steve, there we go. He's jogging away. Clear the aisles, clear the aisles. All right, come on up. We'll let you introduce your panelists. Hopefully your panelists are nearby. Oh, they're coming? All right, so in the meantime, I'll give you some more tips on Copilot. All right. Have you ever had to create a presentation in less than an hour? All right, all the time. All right, and so you could actually ask for text as recommendations to put into those slides, but then graphics. You can also find graphics very quickly. You can ask for a graphic that's on theme. So looks like your panelists are here. I will turn this over to you, Steve. And now for another great fireside chat.
All right. All right. Yes, my name is Stephen Carlini. I'm from Schneider Electric. I'm the Vice President of Innovation, and I will be the moderator today. So I will let the esteemed panel introduce themselves. We're going to talk a little bit about AI, we're going to talk a little bit about data centers, and we're going to talk a little bit about sustainability in 45 minutes. So it's going to be great. So John, go ahead.
Yeah, good morning, everyone. I'm John Fry, and I'm Hewlett-Packard Enterprise's Chief Technologist for Sustainable Transformation. And that means I work with companies around the world to help them use technology more efficiently.
Oh, good morning. Robert Kuchera, Ernst & Young. I work in the cloud transformation practice. My goal is to help people take their technology to the next level and transform it into ways for them to move further operationally.
Good morning, everybody. My name is Eric Quinones. I am one of our chief healthcare advisors at Worldwide Technology, physician. And I get to do a lot of amazing things with a lot of amazing healthcare systems where it comes down to digital transformation. And obviously, we're working a lot with AI these days. But our company does a lot of advanced technology solutions. We serve, about 80 of the Fortune 100. We have a pretty broad footprint, not just here in the US, but abroad. And looking forward to some exciting discussion.
All right, excellent. All right, we've had a lot of people talk about AI. There's a lot of podcasts, there's a lot of videos, there's a lot of TED Talks, there's a lot of panels. I find it very confusing. And hopefully we're going to bring some enlightenment. We're going to kind of talk at a level that hopefully relates to everyone in the room. But the first question we have is, exactly which industries do we feel are ready for AI at this time? AI is not new, by the way. AI has been around for 50 years, and it's been evolving. It's just lately that it's seen this tremendous, momentum and impact. But John.
Yeah, I think this group of tools, and I agree, has been around for 2 decades or more. But what you tend to see is industries such as manufacturing in terms of device or product inspection. You see it in financial services, fraud and risk control in many cases. I'll let Eric talk about the healthcare implications, but we tend to see it across a variety of industries, a lot of interest and a lot of people considering it, but a fewer number actually implementing it yet. But we think that's going to change very dramatically, and I think that's why we're here.
And to tee off of that, the one thing I notice a lot right now in the industry is not so much, who's using it the most or what sector. It's what I'm seeing is a lot of the born in the cloud companies are leveraging it first because they're already able to get to the harness of the technology quicker. Whereas a lot of your traditional or smaller data centers, it takes a little bit more time to get it to be leveraged. So a lot of your 100-year-old companies are a little slower to adopt than like your Facebooks of the world or your newer companies. So it's a bit of adoption as well.
Right. Yeah, AI has been around since the 50s, believe it or not, and it was birthed back in New Hampshire, in Hanover, New Hampshire, or Dartmouth, and so fast forward, I would say in the last year and a half, we knew it was there. It's been utilized in a lot of different industries, but I would think for the general population, it really has become democratized when we look at large language models and Gen AI, et cetera. So that really kind of opened our eyes to the possibilities. And where I see it today in healthcare, there's a lot of interesting use cases that we've been using it for a while, but using it even more so when it comes down to, and I can give specific examples if you want to do that now.
Sure.
Okay. So, when you think about, I think with healthcare, it's a really unique industry. To kind of level set, we are in a bad spot right now in healthcare. And I think you read this stuff on the daily when it comes down to the news. We have a real resource problem. We don't have enough clinicians to care for the population that we have. In 2030, we'll be about 140,000 physicians in the whole. We just don't have that many physicians coming up really soon. We're low right now. In nursing, that's even a bigger problem. So, and we'll never have enough. We just can't train them fast enough. So we don't have enough folks to care for an aging population. So in 2030, every baby boomer will be 65 and over. That's about 20% of the population. That accounts for more chronic care, more chronic disease that needs to be monitored. We just don't have enough folks. So we need to look at technologies to help bridge the gaps to care for these populations. Another thing is just the cognitive overload that clinicians have to be able to do their job is overwhelming. If I wanted to stay on top of my specialty, emergency medicine, I have to read about 20 hours a day just to be up with the science. In 2050, medical knowledge doubled every 50 years. Today, it doubles every 74 days. I can't do that, okay? So I need tools to actually help do that. So we're seeing tools when it comes down to clinical decision support, when it comes down to diagnosis, using radiomics and digital, I would say computer vision, to be able to help radiologists identify pathologies ahead of time. And it may be really urgent things that they may not get to because they have a list of patients they're going through, but this needs to be prioritized so it gets brought up to their attention. Digital pathology to identify, again, pathologies that are going on that we may not see immediately or we may miss. So there's a lot of other instances. I can go all day on this, but I'll pass the baton.
All right, no, that's great examples. So as far as the specific technologies, we talked about the co-pilots. We were just talking about that. That's becoming, everywhere. It's ubiquitous. Every time, would you like Microsoft to analyze what you just said? But there's also digital twins. There's predictive analytics. There's autonomous agents.
Right.
So are there any of these technologies that we're seeing? I mean, everyone's familiar with ChatGPT, and that's what people think, AI is, but there's lots of other examples. So workflow automation, I think, is a big one. So do we have any other examples that anyone wanted to cite?
Sure. So I think a big one is so we can't be everywhere at the same time. So being able to have technologies to use for clinical decision support. So we're pretty good at, taking care of a patient in front of us, but it's when you're taking care of a large panel of patients, whether it's in the hospital or you're, ambulatory, you have an ambulatory practice and you're taking care of patients like in family practice, to know what patients are at risk in any one of those situations, that's very difficult. It's a very reactive type situation that we deal with today. But we're seeing technologies now to be proactive, using clinical decision support, to be able to identify patients and stratify them that these patients are at risk for decompensating, for example. And then we can actually get ahead of it before it actually ends up being a bad situation. So if it's in a hospital, I'm able to identify a patient that may be potentially having pulmonary embolism because the data is showing that in real time that this patient is trending in the wrong direction, or maybe sepsis. So we're able to take that patient and put him in the ICU quickly to avoid a real disaster situation. But on the other side, when you're looking at patients, monitoring patients at home, again, it's very episodic type care we get, but if we could have longitudinal care where patients are monitored at home, and let's say a patient with congestive heart failure, to identify that patient has been gaining, say, 2 pounds over a few days, we know that they're going into heart failure. Instead of them having a real exacerbation and going to the ED, which outcomes are not as good, cost more money, but if we're able to identify them and then have the nurse practitioner bring them into the clinic to diurese them, the outcomes are better, cost less. So again, we're seeing those technologies really being utilized today. It's not the future, it's happening now.
I see a lot with the predictive analytics right now in the financial operations of data center spend, cloud spend, because right now a lot of that is very reactive, as you were saying, not proactive. And so by being able to leverage the predictability and understand where you're going to be or where your trends are coming from over a long period of time, to be able to get in front of it is one area where we're seeing a lot of financial savings in the long run in your data centers and as well as in the cloud.
Yeah, and I'll give just a couple other examples. One of the challenge we have with AI, frankly, is energy availability, and particularly renewable energy availability. So one of the things that you can do with AI systems, for example, we have a customer that we do this with, is they are in the wave energy business. And so the intensity of the waves is very important to energy output from these systems. Well, it turns out you can actually predict, using predictive analytics, wave intensity about 2 weeks out so that you can optimize the energy generation and figure out where the waves get so intense you need to keep the generator, because it's in essence a floating buoy underwater, where you can keep it from actually moving if the waves are too intense. So using AI systems, we can actually optimize that energy output and do that in a predictable way, unlike often wind and solar sources that have a much closer in window of predictability. And then the other side of that equation is, how do we predict some of that energy availability and couple it with workloads? Because when we think about data centers traditionally, we think of they always have power, we can run workloads 24/7, but not all workloads need to run 24/7. Actually, many of them can be scheduled. So if you can use both digital twins of the data center and the implications of any particular workload, and even model different workload scheduling in advance, then you can couple that with energy availability and do a much better job of matching load.
Do you see energy storage, either before the meter or after the meter, becoming more prevalent than it is now, with the grid becoming more distributed?
It's going to have to be, is the answer to that. And there's a tremendous amount of research at here in the United States, the National Renewable Energy Lab up in Boulder, Colorado, and others in the Department of Energy around storage technologies. You're seeing some of it scale. Actually, just about 30 minutes north of here is a very large solar and storage installation that was stood up in the last year and a half. So we're seeing that interest. We're also seeing other storage technologies, like, for example, how do we generate green hydrogen and use hydrogen as the power source? That's been in place for a number of years. HPE did some research with the National Renewable Energy Lab a couple years ago because they have renewable generation on site. And so the question was, how can you bank excess renewable energy when it's being generated, so that when the wind is not blowing or the sun's not shining, you can then use that bank? And actually, their conclusion was bank it as hydrogen and then use the hydrogen to power the IT load. So you may or may not know, in Europe, industrial trucks have used hydrogen-powered motors for a long time. And you can stack 2 of those in an IT rack and provide about 60 kilowatts of power. So this is what NREL actually did and mocked up. And it actually had a huge decarbonizing impact. It became a storage array that was really predictable, and typically you can make that hydrogen from water. And interestingly enough, there's a symbiotic relationship, because if you take the heat load off the IT and heat up the fuel cells, they actually get more efficient. So it's a really interesting symbiotic relationship, and if you get that heat hot enough, then you can use it to heat the buildings, snow removal under the roads, and other beneficial uses as well.
Yeah, and I think, they talked about it at the last panel, like what's the #1 question, or what do people really want to talk about? That's by far the question that I get is, we have AI and it has tremendous momentum, and we have the capacity of data centers, exponentially expanding. Because AI is not going to happen by magic. There's going to have to be a data center infrastructure, a network capacity infrastructure put in place to enable all of this. And the question I get is, aren't we already strained with from utility power? But there are things that are being done, and it is becoming more complicated, but it is manageable to actually build, in the next 3 years, the capacity of data centers that we have planned, in a way that we don't starve out the other industries. So as far as back to AI, we talked about how we're using it now. In the future, especially healthcare and process automations, other industries, do you see? And people are so worried. That's the other question I get is, about their jobs. How is this going to affect my job? And that's a very, very valid question. And it's a question that a lot of companies have to be very careful with. But as we automate more, do we see AI replacing a lot of the core functions that are done in certain industries like healthcare?
Great question. I hear that question all the time, and I'll just say from the clinical standpoint, from the practitioner standpoint, AI will not replace a practitioner. It can't. It's an assistant. However, practitioners that do not use AI are very likely to be replaced, because you just can't keep up today. Okay, so that's one thing. And I think, because of the things I mentioned previously, that the demand that we have on the resources, that we have to use these technologies to be able to help, bridge that gap. It's not going away. It's going to get more intense. It's really going to be a kind of a hockey stick kind of a situation where we're going to need more of these technologies. So we're going to have to be cognizant in how we are actually, curating the data. Data governance, I think, is very important, that we haven't really talked about. And then, how are we going to be storing that data? Will it be a data center? Will it be cloud? Will it be hybrid cloud? Those kinds of things. But in the future, what I see, and this is my opinion, but I think it's a shared opinion. The holy grail for us, or for me, is really precision medicine. So very personalized medicine. So this is looking at a lot more data. This is looking at your genome, your biomes, so your microbiomes, so your gut biome. There's a lot of data there. We're looking at obviously your EHR data, your clinical data that we have, your lifestyle choices, your social determinants of health, environment. So taking all that data into account to be able to be more predictive and to know that, hey, you really are at risk for colorectal cancer, okay? And we need to have you screened earlier. Now, some would argue maybe payers wouldn't agree with that. But no, payers don't see that as a bad thing, because guess what? If I'm able to identify it sooner, and anything we can do better, we can do in medicine, if we identify things sooner, outcomes are better. So if we can identify it sooner, outcomes are better, and it's not a really, expensive situation, we'll say, and outcomes are going to be worse if we wait. So payers we would like to identify it sooner, to be able to treat the patient where it costs less, as opposed to where it can cost more. So precision medicine and personalized medicine it's going to happen. So we can't do it without it. So.
Yeah, and I think going into that, into like the technology side of it, and the going and losing jobs. I know even as when cloud first started coming around, people are thinking, I'm in the data center, I'm going to lose my job if I go to the cloud. It's the same thing with AI. You're not going to lose your jobs. They're just going to change what you do on a daily basis. It's going to evolve, as you said. It's not, if you're not doing it, you'll be left behind. So I do think that at some point, everybody's going to have to leverage it in some way, some facet to do efficiencies. But what you do on a daily basis will get better. It'll actually help you to do more of your real work and not,
Right.
Gets rid of the mundane stuff and the things that you have to do daily and actually do things to ingrain and grow the business.
Right.
So there was some discussion in the last chat about knowledge management, and there's this new C-level position called the head of AI, chief AI officer, whatever you want to call it. And you would think, logically, that would be like a CFO is supposed to optimize the financial performance of the company. You would think the AI officer is supposed to optimize the performance of AI technologies. But a big part of their job is protecting the company and making sure the AI is operated in an ethical way, and it doesn't release all the company's IP, and it doesn't release all the personal information of everyone in the company, which it has the potential to do. So are there any ethical concerns we see in industries that we need to highlight?
100%. I think like at WWT, we really, when we work with our clients, we from its soup to nuts, one of the things that we do implement is the UNESCO 11 tenets of responsible AI. So I think that kind of is our guideline when it comes down to looking at responsible AI. But I also think, so we talk about, security, data, and those kinds of things. But I think responsible AI, for me personally, is also the models that things are based on, right? So as a physician, I will never put my license on the line when it comes down to treating a patient when I don't know what this little magical thing is telling me that I should be doing this. Well, what's the science based on? The little black box situation, we don't do that. So we need to know what the science is based on, what the algorithm is, right then and there. I can't make a decision based on some, something that's anonymous to me. So we can't just do that. So that's one. So I think about that when I think about responsible AI. I think about how was the model built? Like what was it based on? Did it take into account marginalized populations? A lot of times, no. So that's a big problem. And then do we have all the data that's necessary, or is it's partial? Again, that's kind of what I just said, but is it partial data? So I think there's a lot more to it than just the other things. That it's just really how the models are built and what they're based on.
And I think it really stems down to having proper strategy, a governance model, having security involved at the beginning as you start to build this out, because they're going to be the basis to make sure that it gets taken off the right way, because it's very easy to train these models or do things with them, where it does become an ethical or a challenge. So I think it really starts with proper strategy, governance, and then having the right security assets around it, and then making sure you're using it for the right functions, but don't take the total people element out of it.
Right. Yeah, and I would add to that more and more companies are going to have committees that look at that specifically for their AI solutions. At HPE internally, we have a committee that looks at every internal use of AI, and we do the same for customer solutions that we bring to market, partially because so many customers that are considering AI solutions, often the very first thing on their mind is that responsible AI piece. How do they avoid bias? How do they avoid doing something that would have negative consequences for their customers? And we even help them think through, and how could this system be used unintentionally or intentionally to create bias or an untrusted environment? So I think all of those aspects come together that for us, that's almost a bedrock of any AI solution. You've got to consider that and think through the unintended consequences as the solution is being built or even before the solution gets the green light to move forward.
And I think it changes too, depending on the environment you're in. Like if you're heavily regulated, it becomes more impactful. So I know like we're heavily regulated because we do so much tax and audit EY. So, but I know that healthcare would be the same way. So that even twists the knob a little bit more of why you need some sort of a committee or board.
Exactly.
Yeah, and a lot of the training clusters right now are going through, billions and trillions of data points. But as they're deployed in the field as working inference models, they're going to be deployed as scaled down, compressed versions of that model. So they're not going to have all the data that the trained model has. Is that a concern that it may not be as accurate if you're doing healthcare at home, for example, and you have these models that are operating on 50% of the data that they could have? I mean, is that a concern, or how do we see AI moving from training to inference? Because that's where we are right now. Everyone is talking about these clusters and all these data centers that are being built that are enormous LLM models or different types of models that are being developed now, moving those into the field. How do we see that being done in a sustainable way or a technical way?
Yeah, so let me state the obvious right out of the gate here. AI is often a solution in search of a problem. Instead, we should say, what is the business outcome we want? What does it take to get that business outcome? And then consider, is AI the best tool to do that? So first start there. And then once you've determined that an AI solution is the right answer, then it's, can I use something off the shelf? Do I have to use something that's fairly well there, but I just need to tune it with my particular data set? Or do I actually need to start at the beginning with raw data, build or train up a model, and go from there? And one of the conversations is often to the point that data compression, we're actually trying to drive that as efficiency folks, saying, look at the data set you're about to train your model on, and first make sure every bit of data in that data set is applicable. So for example, if you think about large language models, there are data sets out there that are just a crawl of the World Wide Web.
Right.
Well, so much of that data, though, is machine language. It actually contributes nothing to the quality of an answer from written resources. So first, strip that out. Second, if your model can't do translation, you're going to have to narrow the data size to the language that you're actually trying to train the model in. So much of this compression is actually very beneficial and what we ask. Two, a lot of the tools, the better tools now, will look at data. If you have to retrain that model, they'll say, well, wait a minute, we've already processed all of this data. Let's only go find the new pieces, process that, add it to the whole, versus start the training process all over again. So these are all the implications that you need to consider throughout this process, purely from a data efficiency perspective. And I'll just warn everybody, so often we say, well, we're going to give it all the content our company has and train it that way. If you think about what your companies are storing today, you've only ever used about 1/3 of the data that you hold. So our companies are data hoarding. The default answer is capture everything and keep it forever, often on tier 1 or hot storage, which is the most expensive way to do it. Instead, let's get that data pool small enough so that we don't have the environmental implications that we would have starting with the raw data.
Yeah, and I think a lot of times too, if you take all the data, you're taking old data that's maybe stale and irrelevant. Now you've got newer, more recent data, and it confuses the models too, and it makes some of the, what you're trying to find erroneous, right? So you start getting about a lot of bad information back.
Right. Healthcare generates 30% of the global data. A lot. I think an average healthcare facility has about, I think, generates or has 50 petabytes of data, which is significant. And next year, I think will be 36% of the global data. Why? We generate a lot of data because we see patients, and two, we have to keep that data for obvious purposes, for legal reasons, medical legal reasons. So we can't just get rid of the data. But one of the other problems we have in healthcare. So has anybody here ever only seen one doctor in their life? Let's broaden that. Has anybody only gone to one healthcare system in their life? Okay. So we travel, we move, we go to different places, we see different clinicians, providers, across the U.S. But the problem we have in healthcare is that data is not shared. So if I go to healthcare system A, yeah, it may be shared within healthcare system A, and I've even seen situations where healthcare system A, through acquisition, have purchased other organizations. They're still under the same name, but they don't share data. So if I go to another healthcare system, completely different healthcare system, they may not share data, especially if they're in a different EHR system. So that's a big problem. When I don't have the data, the patient data, to be able to care for that patient from a longitudinal basis, that, yeah, you may have seen somebody a year ago and had a lot of tests done, very expensive tests, and then you come and see me, and then I have to reorder those tests when I really shouldn't have to had done that. But I just didn't have access to that data. So that's a big problem, so that we generate more data. So it's a big, big problem in healthcare.
So from a data center perspective, we're training all of these models. We're in the midst of finding applications for these models that are going to be useful and help society. Are we, as an industry or as multiple industries, are we able to adequately evaluate the sustainability impact of our IT systems?
It's getting better, let me say that. And part of the reason why is analytics have been around for years in IT infrastructure. But when I meet with customers all over the world and they say, well, I don't know how much power I'm consuming, or I don't know if I keep this device for 10 years versus 4, what are the power and carbon implications of that? Yet those analytics are there. So in many cases, the tools have been in place. The customers, that was not a focus of most IT organizations. But number 2 is we have focused first on the efficiency of the data center building, because the real estate and property folks that manage that, their number 1 KPI is often utility cost reduction. So they're hyper-focused on the efficiency of that side. Technology teams that put the hardware infrastructure in that data center often have zero visibility to the power and carbon implications of their infrastructure. They're measured on keep it up and running all the time. And if that's how you're measured, you tend to over-provision, and workloads vary. So I don't mean that in a purely negative sense. There's a lot of business drivers that they're responsible for. So it's doing a better job of right-sizing the infrastructure. Then, no matter how efficient the hardware stack is, you can still have great inefficiencies in the software application, from the programming language to the coding methods used. And so part of then driving the efficiency is tuning the workload to the hardware stack and make sure they're a proper match. And even taking a step back, do we even need all those software applications? Almost any customer we help transition to newer infrastructure, we try to get them to think through the applications that are running in their data center. And often there's huge compactions between what was running to what they discovered they actually needed. So every tech refresh is an opportunity to keep this efficiency model moving forward. And then finally, we already talked about the data pieces of it, because storage use is just increasing dramatically. Yet we're encouraging people that use technology to first ask the question of their internal community: when we're going to stand up this workload, how much data are you going to collect? What do you need it for? So how do we make sure we're going to use it? How frequently do we need to collect it? And then how long are we going to keep it, and what are we going to do from a disposition perspective? Make all those decisions up front rather than spinning the workload up and then trying to make them down the way.
You know, I've seen over the years, nobody really used to care about, how much power, how much consumption. It was more of a little bit of cost, or how much carbon footprint am I saving? Nobody cared. Now recently, and I think a lot of this is because of it's coming from the top down, we need to see these metrics, we need to see some guidance, we need to have some, how are we saving on energy? So it's become a big ploy now where the data centers and the people actually need to think and care, and they're starting to look at metrics, but I don't think the metrics are super accurate, because you'll ask people and they'll go, I think, right? Because nobody's 100% sure, because it's not been important until now recently. They just want to do the tech, they just want to make sure the hardware's running. They don't care about how much carbon footprint they're saving. So where I'm seeing it really is coming from the top down, asking for, we need to find out where we can show this as a metric, a KPI, because it looks really good on the news.
Right. So we have clients coming to us all the time, really concerned about this because they're, you know, there is a growth in their data centers, and how do they address it? We really have a practice at WWT that literally focuses on this, on sustainability for data centers. So they'll do, like, from beginning to end. They'll really evaluate the environment. What is the best strategy going forward? What are the tools that they need to be put in place to be able to monitor these things? And they do an amazing job. But one of the other things that you mentioned, I think, is important. So there's the data, but then there's that software layer. So the software or application justification, right? I don't know what the numbers are. I remember hearing some CIOs saying they have hundreds of applications that are not even being used. They're just legacy applications they've had laying around for years, either at that institutions or through acquisition, that they just have laying around. So that's one thing, but then that also brings in a different topic, but a cybersecurity issue as well. So, you know, addressing those things as well. So you kind of hit two birds, one stone when you can justify, you know, getting rid of a lot of extra applications that you don't need from a, you know, a sustainability standpoint and also a cybersecurity standpoint.
You definitely see it more in your older companies or the ones that do a lot of like acquisitions, attrition. They're the ones that typically hang on to all the old stuff, right? They bring in all that technical debt because, hey, we just bought this company, let's bring in all their software because everybody needs it, and we're in a hurry, we have a deadline. And then next thing you know, nobody ever does anything with it because they go back to their day jobs.
Yeah. So I hope you heard us say collectively then, this is one more lens that technology leaders need to consider, along with cyber resiliency and a whole lot of other things. You can't just solve for sustainability or efficiency, because that's going to lead you to bad decisions that impact somewhere else. So think strategically, add this other lens in. And in fact, why are they doing this? We actually commissioned some research and asked senior technology leaders around the world, why are you implementing sustainable IT programs? And those early adopters, fastest moving companies said, to attract and retain institutional investors. Our investors or institutional investors are already calling the board or the CEO and asking about these programs, and we need to have good answers. For most of the companies in the middle, that 70% or so big middle, they said to attract and retain customers. Our customers are already asking about our own environmental credentials, and if we're a technology-oriented company, they are certainly asking about our technology operations. But those more conservative, slower-moving companies at the end, they actually said, well, we found an interesting thing. We're doing it to attract and retain employees because younger generations want to come in and do this technology work, but there's so few of them. They want to work for a company where they can see they're making a difference and they can see how they're contributing to that company's purpose, and then see how that company's purpose contributes to a greater purpose. So as technology leaders, if you're having problems finding and keeping this younger generation of technology employees, make sure you connect your efforts to what you're doing to drive efficiencies in your business through your technology operations, and that may help you very well attract and retain these folks.
Yeah, we've definitely seen that, as you know, Schneider. And Schneider was funny because 6 years ago, when our CEO John Pascal was on CNBC and he said shifting the company's focus towards sustainability, they were like, "Well, that's not a business. That's just something you do to be responsible. You can't make a business out of that." And he's like, "Well, just watch us." And it was very, very unpopular at the time because people didn't understand that there was lots of reasons, and the amount of employees that apply for positions with companies that have a good sustainability reputation versus not is just incredible these days. But do you think the data center industry is getting a bad rap? As you know, there is some, you know, negative sentiment that, you know, these data centers are being built at very fast rate and they're you know, using a lot of the power. Does anyone have a comment on that? Because in my opinion, data centers are way ahead of a lot of other industries in their their use of sustainability and carbon neutral and the path to net zero.
So I was in Europe last week speaking to a group about this size of data center operations type of people, and that's exactly their point. We're doing all these things, we don't get any credit, and people are looking at technology generally in a negative sense. And part of the conversation is, if they're doing the right things, and yes, they're meeting constraints. There are places in the world right now that say you can build it, but we won't hook that data center to the power utility because we literally don't have enough energy to power that new data center. Or countries that have said we're imposing a moratorium for a period of time. So the other side of that conversation, though, is technology has a huge decarbonizing capability. In fact, some independent organizations looked at that, said for every watt of power we consume to run technology, we can decarbonize 10 watts somewhere else. The challenge for all of us, though, is when we drive efficiency one place, we're not happy there. We just go get another device to consume that power that was saved from the first place. So we really do ultimately need to do a better job of being good stewards of every watt of power that we're consuming. And that's the message, I think, that data center operators, cloud operators, they're an integral part of what we need to live life today, but they do have both a footprint, that negative consequence, but a handprint as well, those positive consequences.
And I think that's where the efficiency of your applications and the efficiency of the way the code's written will help not necessarily need as much hardware or cloud space, which then will help reduce some of the carbon footprint as well, right? And some of the, like the power, instead of just, hey, I need to spin this up, let's go add more servers, we can now be more efficient about that.
Right. Yeah, I think about the data as well. So if the data is not curated, if it's not, I want to say clean, but if it's not, there's not good data governance, you just have a lot of data. And then you still have to go sift through that. For example, in healthcare, I think about 80 to 90% of our data that we work with is non-discrete data, okay? So it's text data. So we have to convert that data using natural language processing to discrete data. Okay, so then once we do that, then what of that data do we really need? So we don't need all of it, but there's some things that we do need. So I think that's important. I'm seeing a lot of, so before, I would say 5 years ago, 10 years, definitely 5 years ago, there was this resilience for healthcare systems to not want to build their own data center. They would build their own data center maybe 10 years ago. And then now, because of cybersecurity issues, we're really paranoid for good reason. But now I'm seeing more and more healthcare systems shy away from that. They're actually leading the forefront when it comes down to looking at, hybrid cloud environments, and not building their own data center. I mean, that's still a data center in a way, but it's not on them so much where they're, building their own data center. But that's another topic, I guess.
Yeah. No, I totally agree, because that's one thing that I've seen in the industry is healthcare was not quick to adopt. Right. And now they are, and it's mostly hybrid data centers. So you still have, now you're touching, like you said, right? Two different types of footprints that still need to be monitored.
So I guess to sum it up, AI is here. It's the beginning of the journey, even though it's been around, for 70 years. It is, in a lot of essence, the beginning of where it's going to go and how it's going to be used. And we're going to see, more and more, systems and processes efficiencies being driven by AI, to better society. But also it's going to take a lot of capacity from a data center perspective that need to be built in the most sustainable way, I think, going forward. So any other final comments before we ask for some questions? No? We have one question.
Hey, good morning. This is Oscar Soto from Colombia. I'm working for Oracle in the customer service industry, mainly for telcos. We talk here about amazing advantage that AI can bring to our life and society. But do you see a real threat or risk that AI technology can bring for our kids in the future? and this technology could be used to go beyond the ethics. How as a leader, can avoid that? How we can help on that? Thank you so much. Very great discussion. Mhm.
Anybody want to take that?
So I'll just say, is it a risk? Absolutely, yes. Any technology can be used for good and for not good. In fact, I was listening to a podcast on the drive down this morning about AI for cyber attacks and AI for cybersecurity. And are we going to find ourselves in a day that two AI solutions are actually going head to head against one another? And the expert's answer was, yeah, it's probably already happening today even, and the opportunity is going to get worse. So at least from my perspective, we need to understand the pros and cons, the handprint and the footprint, if you will, of any technology solution. AI is no different than them. And think long and hard again, is that the right solution for the challenge? And if so, put the safeguards in place that need to be in place. I also think this is an evolving topic. We're going to learn a whole lot more over the next couple years in terms of people that do it well and people that don't do it so well that we all get to learn from.
Similar situation, I would say, in healthcare. So some very large payer organizations last year, I think in December, were, I would say, they were accused, and I think they were found guilty of denying medical claims, necessary medical claims that were provided for patients. And so come to find out, as a payer, you're supposed to have a human, and that human should be a clinician to be evaluating these medical claims. Well, come to find out, they're using AI algorithms to deny medical claims, which is a big no-no. So now, what I've seen or heard is that some healthcare systems are using AI. Once that gets denied, it gets kicked back to the healthcare system. The healthcare system is using AI to resubmit the claim. There may be some things missing, but the AI will fill it in and send it right back to the payer. So, yeah.
Excellent.
Thank you.
One more question?
Hi, my name is Amanda Ortiz. I'm a software engineer at Dell. Part of my passion of tech and DEI is always thinking of how we can use it for good. And so on this topic of AI and healthcare, my question is, as the technology of AI is rapidly advancing, how can we ensure that these tools are accessible to individuals who may not even have a home address? What innovative solutions or strategies would you propose to bridge this accessibility gap and ensure that marginalized populations can benefit from AI advancements in healthcare and beyond?
Right. I think that's a great question. So we think of, health equity. So one of the pillars of the quintuple aim. And health equity is really there's a lot in that, but people are marginalized and they don't have either, like you said, a home, or they don't even have access to care. But where I can see AI helping in some of those situations would be, I can do a search in ChatGPT-4 or ChatGPT and ask it a medical question, and it may give it to me, and if it knows maybe my persona, it may give it to me in a very clinically oriented way, okay? Something that I would understand because I have my training. But the persona of somebody who may not have that training, I use the example of a migrant worker who has maybe questions and just has some symptoms, can ask that question of, let's say, a large language model, and it can come back to them in terms that they can understand and help direct them to where they could get access to care, maybe locally in where they live. So I think there's a lot of potential. Again, the message may be the same, it's just delivered and curated differently for those that are asking the question. But I think it's, for me, I'm very hopeful for that, because I think it does break down those gaps of marginalization.
All right, we're getting the hook, so thank you, everybody.